it's only really been in the last few decades that craftsmen and we'll kind of lump everybody together that way, right? We'll machinists and um, millwrights and plumbers and all of these trades. It's only really been in the last few decades that we as craftsmen have comprehended the tolerancing of dimensions. Like for years and years, people simply they took pride in making parts to exact sizes. That's how they looked at things, right? Like for instance, if a print was handed out in a manufacturing facility pre-war, you might have seen on that print call out for a 1.5 inch diameter on a shaft, and it may have had to mate with a hole that would also be dimensioned at 1.5 inches. No, so for instance here, you could have a simple drawing like this, right? They would have, here's your shaft. This is the size we want to make it. And this would be handed out to, whoever's going to make this part on a machine. But the mating part for this hole that it would have to fit in would also be dimensioned at 1.5 inches. And so, you can see how that could make some sense if we didn't have to really consider the controlling of the tolerances. We didn't have to really worry about how close maybe we got to that 1.5. So what would happen is, someone would go to manufacture this shaft, and then they'd, create the hole, this mating hole that it had to go into, and they'd make both these features at 1.5 inches, but they'd make them to 1.5 inches until they fit together, right? So they would continue to just kind of clean up and touch up and polish until those two parts fit together. But really, what those sizes ended up being, how would they verify if they were 1.5 or 1.502, or how would they check that? So essentially, what happened for hundreds of years, anybody attempting to manufacture any parts to any specific sizes, there was no way for them to accurately verify that the parts were to the sizes that they were trying to create. So you can see, calling out sizes like this that you could kind of measure with a simple measuring tools would make sense, right? Back many hundreds of years ago, the span of a hand would be used in reference to a part, like a dimension, right? But your hand and my hand are different sizes, so that was just the reference, right? That was that span of a hand. That was a measurement. So now that, we bring ourselves up to our day, and it's really important for us to not only be able to create parts to a very specific size, but we have to verify it. Can you imagine crafters of old being given a modern day digital caliper to verify that they made this shaft and this hole to 1.5 inches? Imagine the deviation in the part size when they can actually check that dimension to 4 decimal places. They may have found that, those two parts fit together, but the shaft was, 0.07 over the 1.5 inch diameter, and the hole was just over 70 thou small, right? 0.993 or 0.993. So, there's no way to know, right? They just made them till those two parts fit. So variations in the size of parts have always been present. But we have to appreciate that even though we cannot restrict this, there's always going to be a variation in part size. It's impossible to manufacture a part to a specific size. There is always a certain amount of deviation. So since we cannot avoid this deviation or this variation in part sizes, we have to tolerate it, right? We have to put up with it. And that's where tolerance comes from, right? So we may have this size, 1.5 inches, but in modern day, if this shaft had to fit inside of a hole, we would never see this to 1 decimal place. We would probably see it to 3 decimal places of an inch, or possibly even 4. And the reason that we have to put, a decimal place, or a certain number of decimal places after that whole number, is that we can actually control that variation in size to some degree. We can't eliminate it, because you cannot make a size to an exact perfect dimension. There will always be a certain amount of variation, but we can control it to some degree. So any interchangeable parts, they do not need to be identical. And that's something that we have to remember. We cannot make a perfect part. So interchangeable parts do not need to be identical. It's sufficient if the significant sizes that control fits lay between certain defined limits. Okay, so we'll look just at this one more time. This 1.5 inches modern day, what does that shaft do? It fits in a hole. Well, how closely does it have to fit? How much extra room is there? How much clearance between this shaft fitting into this hole? How much clearance is there, right? And that's what we're talking about. We have to put up with the deviation. We have to tolerate the deviation. So we have to attach some sort of tolerance to our prints or our parts.